Solving systems of linear equations. I have two equations. There's an understood 1 to be in front of the first equation, where y is. We're looking to do the elimination method because those equations are set up similar to each other, and y is not isolated. If y was isolated, then I'd do the substitution method. Off to the side, it says, what number can you multiply both sides of the first equation by to have opposite coefficients of y? So we're looking to multiply something to the first equation to cancel something out. We can't cancel out your x values. We're looking to cancel out our y values. So I'm looking to make this value here, instead of a positive 1, I want to make it a positive 2, so that when I set that up, it'll cancel out. In order to do that, you multiply everything inside the parentheses by positive 2. When I do that, I'm going to get 10x plus 2y equals a negative 4. And my second equation stays exactly the same. And we set it up and we add them. When we add that, we're going to get 12x. And this is going to cancel out, which is the whole purpose of the elimination method, to cancel out an x or y value. Now this is a little bit different because this is going to equal 0, but that is okay. Our last step to do is to divide by 12. So we're going to get x equals 0. When we get x equals 0, that is only part of our solution, because our solution is going to be a coordinate. Remember, it's x comma y. We take that x value and we plug it back into one of the original equations. It doesn't matter which equation you want to plug it into, but you need to plug it into one of the original equations. I'm just going to choose to plug it into the first equation, which is 5x plus y equals negative 2. And we're taking that x equals 0 and we're plugging it in right here. So that's going to give me 0 plus y equals a negative 2, which is just going to give me y equals negative 2. So my answer, my solution to the system of equations here that we found by doing the elimination method is 0, comma, negative 2. Now, moving on to the graphing portion. It says, part B, graph the systems of equations to check your solution. Well, we can't graph the equations until they're in slope-intercept form. So that's a little bit of work that you have to show at the bottom of part B. We have to put those in slope-intercept form so you know what your slope is, you know what your y-intercept is. So I'm going to copy down the equations from the very beginning. I take these equations up top and I'm copying them exactly how they are. And I'm preparing myself because I'm going to have to isolate y for both of them. Remember, when you isolate y, you are getting y completely by itself. So we're just moving things over. We're going to subtract 5x because that is understood to be positive. And remember, you cannot combine these two values together because they're not like terms. And there we have it. We have isolated y. Okay? I'm going to circle this, and I'm going to write that that is my y-intercept, which is where I start on the graph. And 5 is my slope, but I need to write it as a fraction because slope is rise over run. And that means, well, I made a mistake right off the bat. What mistake did I make? This is a good test-taking strategy, I guess. What mistake did I make? It's not supposed to be positive 5, right? Right here, I subtracted 5, and over here I wrote plus 5. So that should be a subtraction sign, subtraction sign, subtraction sign. So that's actually a negative 5, which would mess me up if I was doing rise over run and I went up, because I'm supposed to go down and to the right. Does everybody see that? Subtract, subtract, and that makes it negative. Okay? I'm going to go ahead and graph that one. I start at my y-intercept of -2. Okay? That's that first coordinate. And I'm supposed to go down 1, 2, 3, 4, 5, but that's not possible because I go off the graph and I go over to the right 1. So my coordinate's supposed to be here, but it goes off the graph. So I need to go the opposite direction. Instead of going down and to the right, I'm going to go up 5, 1, 2, 3, 4, 5, and to the left 1. I'm just going to connect those coordinates as straight as I can, and there's my line. Okay, next equation, we have to do the same thing, isolate y. That's understood to be positive, so I'm going to subtract 2x. I'm not going to make the same mistake, right? Minus 2x, so this should be written as -2x plus 4 because that's positive. Now, here's the difference here. We have 2 connected there, so we have to divide everything by a -2. And a negative is going to give me a positive 1x. Positive and a negative gives me a -2. So I'm thinking 2 divided by 2 is 1. Positive 4 divided by a -2 is a -2. That value there is my y-intercept. Again, that is where I start. One is my slope. I'm going to write that as a fraction. It's my rise over my run. And I go up because it's positive and to the right because it's positive. So I'm looking back at the graph, preparing to graph it. And I'm going to start at -2. And I'm going to go up 1 over 1. I'm going to do that over and over and over. And go the opposite direction. Instead of going up and to the right, I go down and to the left. And I'm going to connect those coordinates as best I can. It says, part B, graph the system of equations to check your solution. Well, the solution is correct. It's right there, and it is 0, -2. Okay, next equation, next problem, is number 2. It says, consider the system of equations. You have your system. It says, tell whether each statement is true or false. So let's look at what we're going to have to do. I have to tell whether it has infinitely many solutions or not. Does it have exactly one solution? Is 5, 3 a solution of the system? And the last one is the equations in the system have the same slope and the same y-intercept. So I know that I'm looking for infinite solutions, one solution. Is that one of the solutions, 5, 3? And does it have the same slope and same y-intercept? So I don't need to solve this and find the point of intersection just yet, because most of those choices have to do with number of solutions. So what I need to do is figure out what is my slope and what is my y-intercept. And the way to do that is to isolate y. So I'm going to take both of those equations exactly how they are. I'll go down to the bottom and I'm going to rewrite them. 2x minus 3y equals 1. Draw my double line because I'm going to have to isolate it. Same thing with the other one. 9y equals 6x minus 3, and draw my double line. Now I'm isolating y here to see what my slope and y-intercepts are. Okay, so there we go. First thing I have to do is subtract 2x from both sides. Cancels there. I'm left with a negative 3y equals, and we can't combine those together, so I'm just going to write that as negative 2x plus 1. And my last step is to divide by negative 3. I'm dividing here because that's connected with multiplication. The opposite of multiplication is division. So I get y equals a negative and a negative, make that a positive 2/3, and x just sticks right next to it. Positive and a negative, make that a negative. So let's write that as minus 1/3. Okay, so there is my y-intercept. There is my slope. The next one's a little bit shorter because all I have connected to y is 9, and it's connected with multiplication, so I need to do the opposite and divide by 9. So I get y equals 6 over 9x, and that's going to be a negative 3 over 9. But those two fractions can be simplified. So I have to take 6 over 9, think to myself, okay, what can go into 6 and 9? And the answer there is 3. 3 can go into both of those. And so that's going to give me a positive 2/3. And then same thing with a negative 3/9. What can go into 3 and 9? 3 can go into those. So I divide the top and bottom by 3, and I get a negative 1/3. So I go back and I put those in the correct place, and I get 2/3 x minus 1/3. So that is my y-intercept. That is my slope. Now, looking at both of those, I can see that they're the same exact thing. They're the same exact equation, and when we have something that is the same exact equation, it's infinite solutions because it's going to intersect everywhere, the same exact line right on top of each other. So let's go back to those choices that we have. And let's look at them. Let's check them off. The system has infinitely many solutions. Absolutely, yes, true. The system has exactly one solution. No, it does not. It doesn't have just one solution. It has infinite solutions. Remember, if it has one solution, the slopes are going to be different, and it's going to intersect only once. C is a little bit tricky. It says 5,3 is a solution of the system. Well, is it a solution of the system? Yes. Yes, it is, because it is going to pass through 5,3. You can test that out by plugging in 5 for x and 3 for y, and it does pass through 5,3. It is not the only solution, but it is a solution to the system of equations. D, the equations in the system have the same slope and the same y-intercept. That is also true. That is also true. Moving on to the next question. All right, number 3. The Parks and Recreation Department in your town offers a season pass for $150. With the season pass, you get $5 per session to use the town's tennis courts. Without the season pass, you pay $15 per session to use the tennis court. So you have two scenarios here. You have a season pass and no season pass. So let's go back. Let's read the first question. It says, write the system of equations to represent the situation. System of equations means two. You have to write two equations, which makes sense because you have two scenarios here, a season pass and no season pass. We're going to go back and we're going to read what we think is important here. I have with a season pass, so with pass and without pass. Okay? So the Parks and Recreation Department in your town offers a season pass for $150. per session, and without the season pass, you pay $15 per session. So with the season pass, it's cheaper per session. Without it, it's a little bit more expensive. To write that as an equation, we're going to write y equals for both of them. And we need to think, okay, well, where is there an upfront fee? What do you just pay one time? And that is with the season pass. With the season pass, you have a one-time payment of $150. With that one-time payment, you have a reoccurring expense, a rate, a slope, a unit rate, rate of change, whatever you want to call it. Per is a key word to hint that there is a rate, and that is going to be $5 per session with $150 up front. This is your slope, your reoccurring rate over and over and over. This is your one-time fee of $150. That's where you would start on the y-axis, because you may pay $150 for a season pass and you may never go, so you would still pay $150 no matter what. That's your upfront fee, just to buy the pass. Without the pass, you have no upfront fee, so your y-intercept would be 0, and your rate or slope is 15, because it's $15 per session. The next part says, graph your system of equations. How many times do you need to use the tennis courts for the season pass to have saved you money? So at some point, it will be cheaper to have the season pass, and at some point it won't be cheaper to have the season pass. It all depends on how often you plan on going and using your session. So, going down to the bottom, I'm going to take those equations, I'm going to rewrite them. And I'll do y equals 5x plus 150. This is going to be with the pass. And this would be my y-intercept. And I have a slope of 5. So I'm going to start at 150. That's my y-intercept right there. Slope of 5 can be a little bit confusing because your axis is not going by 5s. It's going by here 25s, and here it's going by 5s. So you have to think, we're trying to look for equivalent ratios, which is something that you've done in the past grades. And since it's going by 25s, I'm going to say, well, how can I get from 5 over 1, which is the same as 5, to 25? Well, how can I do that? To get from 5 to 25, I multiply by 5. And we know if we multiply the top by something, we have to multiply the bottom by that same thing, and that would be 5. So truthfully, when we're doing our slope for this problem, we're going to rise 25 and run 5. So we're going up 25 and we're going to run 5 over and over and over. Now it looks like we're going up 1 and over 1. Well, that is true, but it's also false because we're not really going up one value. We're going up 1 unit, but the value of what we're going up is 25, and the value of what we're going over is 5. So we are doing what the slope is telling us to do. Now, the other equation, which is without the pass, we said that that was just y equals 15x. Well, there's an understood to be plus 0 there, so we're going to start at the origin. That's my y-intercept. And this is my slope. But again, it's tricky because you don't go up 15. So we have to figure out, well, how much do I actually need to go up to fit it on the graph in the right spot? So I'm going to write 15 over 1. And we're looking for something equivalent. What I'm looking at on that graph, I'm looking at the coordinates on the y-axis. And I'm looking at, okay, I have 25, 50, 75, 100, 125, 150. Well, I know 15 can definitely go into 150. But I also know 15 can go into 75. Okay? So how do I get from 15 to 75? I need to multiply 15 times 5. And you can check that with your calculator. 15 times 5 is 75. But whatever I do to the top, I have to do to the bottom. So 1 times 5 gives me 5. So truthfully, this is my rise over line. It's equivalent. It's the same value because I did the same to the top and the bottom. So I need to, where do I start? I start at the origin because I have no upfront fee without a pass. And I'm going to go up 75 and over to the right 5. So 75, 5. And I go up 75 more over 5. I go up 75 more over 5. I go up 75 more over 5. And best I can, I'm going to make this line as straight as I can. So this is without. And the other one is with the pass. So let's look at it. The question again says, graph your system of equations, and says how many times do you need to use the tennis courts for the season pass to save you money? Explain. So let's look at it. If I use the tennis courts, and I'm not using the pass, if I use the tennis courts 15 times, that's equivalent. That's the point of intersection. That would be called the solution to the system of equations, but that's not what it's asking here. It's asking how many times do I need to use it to save money? So here's the big picture. If I'm trying to decide if I get the pass or not.
Excuse me, teachers and students. Students who received their limo ride invitation, the white group is ready to leave now at the front of the school. The white group for the World's Finest Chocolate Limo Ride, please meet at the front of the school. Thank you.
So I'm trying to decide if I need the pass or not. If I plan on going less than 15 times or 15 times, it doesn't much matter. It would be cheaper to go without the pass. But if I plan on using it 16 times, not 15, because 15 will be the same value, but if I plan on using it 16 times and going to 16 sessions, then I need to go ahead and get the pass, because after that, it would be cheaper. So here's how we're going to word that. Okay, I'm going to go back up to the question itself. Part B. How many times do you need to use the tennis courts to save money? 16 times. I'm going to write playing 15 times will cost the same amount, which is $225. I got that just by looking at the graph. They use 15 sessions, $225. And that's with or without the pass. Playing 16 times will cost $230 with the pass, and it would cost $240 without the pass. And how did I figure out those last two numbers there? I took that value and I just did some quick math of plugging it in right here and right here, and that'll give you your value. If you plug in 16 here, solve it out, that's with the pass. Plug in 16 here, Without the past, it gives you your value. Okay? Moving on to the next question, number 4. You have two lines here. You have line A that passes through the coordinates -3, -2, and 0, 4, and you have line B that passes through the points -2, -3, and 0, 1. It says A, lines A and B intersect. True or false? Lines A and B have different slopes. True or false? Lines A and B have different y-intercepts. True or false? And lines A and B are parallel. So there's only one of those that I can answer right now. And it has to do with that hint that's given to us. It says, remember, off to the side, remember that the y-intercept is the y-coordinate when the x-coordinate is 0. So right now, I'm looking at these two right here. Those are my y-intercepts. So do they have different y-intercepts? Yes, they do. The rest of those, we have to do a little bit of work to figure those out. So I'm going to do line A on this side. How do you find the slope of two coordinates? Well, you have to find the change in y divided by your change in x. Now, my students like to set it up as a table. First coordinate first, second coordinate second. And I like to do that as well. So x comma y. And I'm looking at line A. So my first coordinate is a -3, -2. My second coordinate is 0, 4. And from there, I have to find the difference and the change in y and the change in x. So I think to myself, okay, well, how do I get from -3 to 0? In order to do that, I had to add 3. How do I get from a -2 to 4? In order to do that, I have to add 6. And we do change in y divided by change in x. So how does my y change? 6. How does my x change? 3. So that's going to be 6 over 3, which is 2. That is my slope that I was just finding. Okay. I'm going to go ahead and take it a step further, and I'm going to write this as an equation because I have my slope, so that's going to be y equals 2x, and I already know my y-intercept because it's right here. It's 0, 4. So my y-intercept is at +4. That's my equation for line A. All by giving me just two coordinates, you can find your equation. So line B. We're going to do the same process, except different coordinates, of course. We have the first coordinate is -2, -3. The second coordinate is 0, 1. And we're going to do the same exact thing. We're thinking to ourselves, okay, how do you get from -2 to 0, and how do you get from -3 to 1? Well, from -2 to 0, I add 2. From -3 to 1, I add 4. Now think about what I just did with this problem. It's the same exact process. Your change in y divided by your change in x. So I'm going to take my 4, which is my change in y, divided by 2, which is 2. And again, that value that we just found, that's my slope. So I'm going to write my equation for that one. Y equals 2x. The difference is, you don't have a y-intercept of 4, you have a y-intercept of 1 because it's a different coordinate that you're given. So that's a +1, so write +1. Now, let's go back through those choices that we were given. Lines A and B intersect. Well, you have to think back to your number of solutions. Are they going to intersect if they have the same exact slope but different y-intercepts? The answer is no. This is actually a no solution problem. Even though that's not your choice there or any of the choices, this is no solution, meaning they're going to be parallel, which answers part B. They're not going to intersect. they're going to have the exact same slope, but they start at different points on the graph. So one starts at +4, one starts at a -1, and they go up at a slope of 2. They're going to be parallel the entire time. So the answer to D is true. They are parallel. Lines A and B intersect. The answer there is false. They do not. And it says lines A and B have different slopes. That is false as well. They do not have different slopes. All right. Moving on to the next problem, number 5. Number 5. Roberto got $30 for his birthday. He decides to save that amount and add $5 to his savings each week. Jack starts saving the same day as Roberto, but puts $8 in his savings each week. After how many weeks will the boys have the same amount in savings? After how many weeks will the boys have the same amount in savings? So I know I'm looking for a solution to the system of equations. The problem is we don't have an equation or even 2 equations. So we have to create 2 equations, one equation to represent Roberto and one equation to represent Jack. And how do I know we're looking for a solution? Because it says, will they be the same? Anytime you're looking for the same amount or to meet or to cross, you're looking for a point of intersection. Okay, so let's go through that one more time. It says Roberto, I'm going to do him in orange. Roberto got $30 for his birthday, and he decides to save that amount and add $5 to his savings each week. We have 2 values there. One of those values is going to be my slope. One of those values is going to be my y-intercept. So let's talk about it. Roberto. $30 for his birthday, and he adds $5 each week. Well, which one of those is going to be a reoccurring amount that's going to be added each week? It's $5. Anytime you have a reoccurring amount over and over and over, that's a rate, it's a unit rate, it's a rate of change. We call it slope. So that's going to be your 5 is your slope, and your 30 is your y-intercept. That's your slope. Y-intercept. Okay. Next, we have Jack. Which is y equals again. It says Jack starts saving the same day as Roberto, but he puts $8 in his savings each week. So he doesn't have an upfront amount. It's not his birthday. He doesn't have an upfront amount that he's putting in first. He just has $8 each week. That's what he's putting in, which is more than what Roberto is putting in each week. But Roberto also starts with $30. So we're going to write that as Jack as 8x, where this is my slope. And we haven't understood +0, so he would start at 0 if we were to graph this. But we're going to solve this algebraically. So how do we do this? We would use the substitution method, and in that substitution method, you take one of your isolated y's, one of your equations that has y isolated, and you plug it into the other equation where y is. This one's a little bit different because we have both of them that are isolated. So when I take this equation here and I plug it into y, this is how it's going to look. We have y equals 5x plus 30, and instead of y, I always say we put our y value there. Well, our y value, y equals here, is 8x. So this is how it's going to work. Okay? Now we're to the point where we need to solve. We're solving for x. And I always say letters on the left, numbers on the right. So we're going to move that 5x to the left, and we're trying to get all our numbers to the right. So x is going to be on one side, which is the left, and your numbers are going to be on the other side. So I'm subtracting 5x from both sides. and you get 3x equals 30. You divide by 3 because that's multiplication, so I need to divide, and you get x equals 10. So what does that mean? X equals 10. 10 what? Well, we have to think back to the problem. My y value, that is the total saved, and my x value, that is how many weeks. How do I know that? Well, the y value is how much they save. He saves $5 each week. He saves $8 each week. So my x is how many weeks. That's what that represents. So it says, after how many weeks will the boys have the same amount in savings? The answer is 10. 10 weeks. And I would explain that. I would say, after 10 weeks, Roberto and Jack will both have the same amount. And I'm going to go a step further and say what that amount is. Let's think about it. If it's 10 weeks, well, plug that in. Just in your head, you can plug it in. What is 10 plugged in right there? Well, what is 8 times 10? 80, right? And then right here, if we plug in 10 here, we think, okay, what is 5 times 10? Well, 5 times 10 is 50, and 50 plus 30 gives me $80 again. So that's kind of our check. Roberto and Jack will both have the same amount, $80. And that's where I'm going to end for this video.